Here we go, continuing our work on selection statements, these if-else statements in Python. Last time we ended with this Zodiac example. Just as a warm-up, let's revisit this example. We want to ask the user to enter a year, the year they were born, or some other year, and then we would like to display the correct Chinese zodiac sign. We were given this little wheel to show the signs, and we talked about in the problem-solving phase to determine how we can determine if a given year or which year maps into a particular zodiac sign. It's a 12-year cycle. 0 was the year of the monkey. The next year the monkey would be 12, and then 24, and then 36. Every multiple of 12, which kind of clued us in on the answer here. And we realized that as a result of all of this, we could use mod. That if we realized that the year 36 was also the year of the monkey, as was the year 12 and 24. So if you took that year 48, someone who's born in the year 48, you modded it by 12 and you got a remainder of 0, well, anyone with that remainder of 0 was going to be the year of the monkey. So that's really what it amounted to, was to take the year, mod it by 12, get that result, and then plug it into this long if elif statement, this long multi-way if elif statement. And that we saw, for example, that as soon as one of these is true, and it's worth repeating this, let's just say that someone was born in such a year where after you divide it by 12, you have a remainder of 2, and we're going to print dog for year of the dog. Well, as soon as this statement on a line 7, this elif zodiac year equal to, as soon as that is true, and we print dog, that all of the rest of this is skipped, because the Python interpreter treats all of this as one big multi-way if elif block. And the way those blocks work are, once a single Boolean expression is true, we will evaluate what is inside, what is indented to the right within that true Boolean expression. But then all of the other conditions, like elif zodiac year equals 3 or 4 or 5, all of the rest of those are then skipped. So let us now, we looked at this code, a nice little stretching warm-up exercise, and this was our result. Cool. What comes next? Let's do a couple of practices, and then we're going to jump into something new. So here we have, suppose x is 3, y equals 2. Show the output of the following code. If x is greater than 2, if y is greater than 2, so are they both greater than 2? They're not. So we're not going to even enter. So x is greater than 2, so we're going to enter right here. And then this if statement, y is greater than 2, that's not true. So we're going to come to the matching else, and we're going to print x is 3. Hopefully that's okay. But what about if x is 3 and y is 4? So if x is 3 and y is 4, so x we plug in, x is 3, this is true. So therefore we enter this if statement, and we come and we evaluate all of this right here. And we check y. Y is 4. Is 4 greater than 2? It is. So we now will evaluate what is inside this if statement. And we will not come to this else, because this if statement is true. And z is going to be what? X plus y, 3 plus 4 is 7, and this will print z is 7. But what about this one? If x is 2 and y is 2. So now we say if x is 2, is 2 greater than 2? Nope. So this is false. Well, because this is false, we will not evaluate anything inside this if statement, which means we will not evaluate any of this, and instead, Python, the interpreter, will look for any matching elif or any matching else that is lined up or aligned with this if, and there is none. In fact, nothing is printed. There is no output when we run it with x is 2 and with y is 2. What we'd like to do now is cover some common errors with selection statements. And there's many common errors, but arguably the most common errors with respect to Python is that of indentation. So indentation, as we've seen, is central in Python. Your code, in fact, is completely understood based off of its indentation. If you indent it incorrectly, it will either A, not even run, the interpreter will just tell you, nope, we can't make this happen, or you'll get logical errors because the indentation is incorrect, and therefore Python runs it in a way that you were not expecting because you had incorrect indentation. If you want a segment of code to be executed only under an if condition, like within an if block, then all of that code inside the if block must be indented together as a group. Every line must be indented for spaces. So look at this example. Back to that radius example we introduced and we visited when we first started this discussion on selection statements. Here we say radius equals -20, and then we say if radius is greater or equal to 0, only then do we calculate the area, and only then should we print the area is area. Well, we did that correctly over here. If the radius is greater or even equal to 0, calculate the area and print it. But if it's not greater or equal to 0, we could have done nothing, or I could have put else, error, you entered a negative radius, which even makes no sense. We could have just said, hey, that's not even a valid radius. But look at what we did here. Here, this is wrong. What we did is we said if radius is greater or equal to 0, only then do we calculate the area. But this print statement, instead of being indented inside this if, which would have been correct, because we only want to print an area if we've calculated an area, and if the radius was therefore a valid radius. But here, this is attempting to print the area regardless of radius being greater or equal to 0. Because the only this equation here, this assignment, area equals radius times math.pi, that's the only line of code currently inside the if statement. So if the radius is positive or greater or equal to 0, we'll calculate the area. Regardless, we then print the area. No error occurs, no problem. But what if the radius is negative? If it's negative, we will not evaluate what is inside this if statement, because radius greater or equal to 0 will be false, because -20 is not greater or equal to 0. That's false. So we will not evaluate the statement. And when we come over here to print, we're still going to print because we indented it incorrectly, and it will print the area is area. And Python will say, I don't know what area is because I've never seen that variable. Of course it did not see it because it was conditionally created and assigned only if radius was a valid radius. So this is a common error based off of what I just described, indentation. Another example, we can open this all the way up. Another example here, we have two if statements and we have one else statement. If you look here on the left, we have two if statements and an else. Here we have two if statements and an else. But notice the else statements here, one of them is aligned with this if on the left, and then this else statement here is aligned with the inner if statement. So the question is, which if clause is matched by the else statement? And in Python, it's easy. Other languages, there's more nuances. Python, it's easy. If you see an else and you want to know, hey, which if does this match up with? Just look up and go straight up from the E to find the matching if or elif statement. And that's how you can tell. Same thing here, this E, we look up, we see this matching if statement. So in A, this first box, this else is matched with the outer if statement. Here, this else is matched with the inner if statement. As a result, the outputs are going to be different. Let's study the output. If I is greater than j, is I greater than j? 1 is not greater than 2, so that's not true. So we don't even enter this if statement, which means we don't execute any of this. And because this was false, we come directly to this else and we print B. But now look at this one. If I is greater than j, 1 is not greater than 2, so that's false. And we don't print anything because there's no matching else statement to even come to. Now we have not an error, but a tip. This is a unique tip here. It's kind of cool, something that's like weird at first when you see it. So new programmers will often write code like this. Let's just say that you wanted to know if a number was even or odd. And instead of just printing if it's even or odd, let me come back to my Thani. Where's my Thani? Oh my gosh, I keep skipping it. There we go. Let me close some of these other things that I don't need open at the moment. Don't need that, don't need that. There we go. So come back to Thani and here. So if the number is even or odd, let's just type that in. If, let's make a number, value equals 8. And this is not Java. If value mod 2 is 0, we could normally have just printed val is even, else we print val is odd. Right? This is what we would normally have done. Perhaps just print if it's even or odd. Of course, 8 is even. It should print val is even. If we change value to 11, this should print val is odd. Pretty straightforward. But what if we didn't want to print? What if instead we wanted to keep a variable? Some variable called, what do we call it here? Even? No, let's have a variable called, actually let's call it even. Or is even equals true. And here we would say is even equals false. All we're doing is we're saying, hey, if it's even, which it is, take true and save it into this is even variable. Otherwise, save false into it. The only reason we would have done it like that instead of printing it is maybe later in the program, you have a large program and later on, maybe hundreds of lines later, you want to be able to print out something, based off of what is inside is even. Does that make sense? You could have said, hey, if is even is true, then later in the program we could have printed something based off of if it were true, else we could have printed something else. So imagine we had this scenario where instead of just printing if it's even or not, we're saving a Boolean value into a variable of true or false. Well, in that scenario, a lot of students would write this code and there's nothing wrong with that code. Nothing at all wrong with it. But you can actually write that as one line, which looks funky at first. We could have just said here, instead of those 4 lines of code, I could have just done this. I could have said is even equals val mod 2 equals 0. And that looks super, let me zoom in. That looks super funky, but it works. What's going on with that? Remember, we should always look to see if we have an assignment statement. And here we have an assignment. And when we have an assignment, where should our eyes go? Where should they look? To the right. And we look to the right, and what do we see? Don't be confused. What do we see here? Well, we see some math. We see mod, but what do we see? We should see equals. So we realize, oh, that's a Boolean expression. That ultimately is going to evaluate to either true or it'll evaluate to false. And whichever one it evaluates to ultimately gets saved into this variable is even. So the takeaway is those 4 lines can really be simplified into one line of code. All right, we want to solve a problem together. Rock, paper, scissors. Write a program to play the famous rock, paper, scissors game with the computer. Your program should ask the user to enter their choice for rock, paper, or scissors. The computer will then randomly generate an option and a winner will be determined. Now, I've already started this here for us, so we don't have to type all of this out live. That would be just a waste of effort. So here, we've printed this menu. Notice I put a tab just to practice using this escape character, \T, like we know that \N makes a new line. \T will make a tab. So we've printed out this menu exactly as depicted. And let's even run it, make sure all is well when we run it. We can now enter a 1. I didn't take any action based off of entering a 1, but we entered a 1 or a 2, or we enter a 3, right? Everything is fine. Cool. Now, what do we want to do? Based off of that 1, 2, or a 3, that's the user's choice, we want to compare it to a randomly generated choice from the computer and then see who actually won. So here are some samples to look at. Right? We have a couple of different options. We entered a 3. Here the computer must have randomly chosen a 2 for paper, and the 3 was scissors, therefore the user won. Here the user entered 1 for rock, but this time the computer randomly generated a 3, which was scissors. Your rock, you won. And we have some other examples. I didn't exhaustively put all the different options, but I have one where you won. I really should have included one where you lost, but it just says you lost, exclamation point. Otherwise, we put it is a draw. So problem solving phase. We need to ask the user for a selection, for a choice, 1, 2, or 3. Now we could have let them enter rock, paper, or scissors, but then generating a random choice from rock, paper, or scissors is something we haven't seen just yet. So for now, to avoid that and to avoid dealing with spelling issues, maybe there's a typo when the user enters scissors or paper, for example, we're just going to have the user enter a 1, a 2, or a 3. Similarly, the computer, we need to generate a random number, a 1, a 2, or a 3. And what really remains is just comparing all these options. So notice I've already given the line of code here to generate that random number from the user. So let's do this. Let's type in generate random choice for the computer. And I called it here choice computer. Oh, I can't type. Choice computer equals, and this is random dot rand int 1, 3. That is the computer's choice. So we have the user's choice from 1 to 3. We have the computer's choice from 1 to 3. What really remains here is compare the various choices and print appropriate messages. That's all that really remains. That's what this problem amounts to. But it's worth doing, so let's do this one together. We need to use some nested if as well as if, elif, else statements to do this. All right, so here I've already shown you this first slide of the solution. Page 63 is showing you what we've already seen here. So what comes next? How about we start with checking. Check or if computer chose rock. Let's say the computer chose rock, which is 1, right? So if choice computer is a 1, now what are we going to do? Within this line, within here, we want to compare all of our possible choices. So if choice user is a 1, print something. Elif choice user is a 2, print something else. Else, print something else. So we're assuming the user is going to listen and enter a 1, a 2, or a 3. If they enter something else, well, that we're not worried about in this problem of dealing with bad input. That's something we'll address later. Let's assume they entered strictly a 1, a 2, or a 3. And so let's go through the possibilities. Let's look at the outputs. So if they enter a 1 and you entered a 1, what does that mean? We should print out the computer is rock and you are rock 2, colon, semicolon, it is a draw. So I'm going to print here. The computer is rock and you are rock 2, it is a draw. Easy. What do we want to print here? If the computer chose rock and you chose paper, right? The computer chose 1, but now you chose paper. So the computer is rock and you are paper. And we put a semicolon. So who wins, rock or paper? Let me make this capital P. Paper wins, right? So paper wins. So I'm going to type you won, exclamation point. Easy. And then finally, what do we print here? If it's 1 versus 3, rock versus scissors. So the computer is rock and you are scissors. So who wins, rock versus scissors? The computer won. So I can type the computer won, period, is what I saw right here. Cool. So this all of these choices. This is an inner nested, this is a nested if, elif, else block. And what are we really checking? Check now all the user choices, 1, 2, or 3. And we checked all of those choices strictly only when the computer chose option 1, rock. And we then compared it to all of our possible selections, rock, paper, or scissors, right? Rock, paper, or scissors. Well, guess what? What remains, I'd encourage you to pause the video if you know what to do now. What remains is to do that again. Here, this is going to be elif, choice, computer is 2 now, right? I'm going to highlight this comment. Else if computer chose paper, which is option 2. What do we need to do? We need to once again compare it to all of our choices. So I'm going to highlight all of that code. Why recreate the wheel? You're already done. Paste. We need to compare the computer's choice of 2 to the user's choice of 1 or 2 or 3 and print an appropriate message. So now the choice of 2 is paper, right? So the computer is paper, paper, paper for all of these. And you are rock. This would say, and you are paper 2. This would be, it is a draw. And this is, the computer is paper and you are scissors. So if the computer is paper and you are scissors, this is going to be U1, exclamation point. If the computer is paper and you are rock, the computer one, period. And it is a draw, that should be a period. Not that bad. So now we have all of choice 1 done. If the computer chose a 1, we've looked at all of our choices to match with that 1. Else, if the computer chose a 2, we need to look at all of our choices again and match it with the computer's choice of a 2. Well, what's the final possible choice of the computer? Else, what does this else even mean? That the computer must have chosen option 3. So else, computer chose scissors, which was option 3. And once again, we're going to take all of this right here and we're just going to paste it. When the computer chooses scissors, we're going to compare that to all of our choices. 1, 2, or 3, rock, paper, or scissors. But now I'm going to paste scissors right here because this is all assuming that the computer chose scissors. We're at else, this outer else statement. Remember, this outer if statement was the computer chose rock. Elif, the computer chose paper. Finally, else, the only option left is scissors. So the computer chose scissors and you are rock. The computer chose scissors and you are paper. Or the computer is scissors and you are scissors 2. So what do we do? This is going to be, it is a draw right here. It is a draw. The computer is scissors and you are paper. Who wins with that? The computer won, period. And the computer is scissors and you are rock. Who wins that one? You won, period. Rock beats scissors. So this program is now done. And whatever you put in, we choose a 2. The computer is paper and you are paper 2. It is a draw. I want to put a space right here. So I could come put a new line before every one of these, but since it's so many new lines, I think it's just easier to, after we scan the choice, just make an empty print statement. Let's run this now. The computer's paper and you are scissors, you won. Do another one. The computer's paper and you are rock, the computer won. And of course, I could have seeded this. I could have said, I could have set the seed random dot seed, and I set the seed to the number 2023, the year. And I run this code. And of course, now the computer will always choose the exact same option. The computer chose paper, The computer chose paper. The computer chose paper. That's not very exciting. What I could have also done is ask the user for a seed, but no need for a seed. That's usually used for, it helps for auto grading to make sure we're having the exact same output when we grade. Cool. So here is a solution also in the slides. Page 1 and page 2 looks pretty similar to what we just showed. So some more common errors within selection statements, and here are some checkpoints for us as well. Look at the following and see which is better of these two. Maybe pause the video and think, why would one of these particular blocks of code be better than the other? Because I would argue that B is much better, but why is option B better? Pausing for emphasis. Hopefully you pause the video. Think about that. Why is it better? Well, because the objective here, if you just look at it, age less than 16, you can drive. If you can't drive, age greater or equal to 16, you can get a license. Well, that's the objective of this question, right? To print out they can't get a license or they can. B is better. Why? Because here we're evaluating a single Boolean expression on this if line. If it's true, we print this. If it's false, we print this. But nothing gets evaluated on this else. So we're only evaluating one single Boolean expression. Whereas over here, we're achieving the same objective, but now we're asking twice two independent evaluations of a Boolean expression. It's unnecessary. There's no reason to do that, which is why option B is better. So here's just a couple of problems to practice with that I would encourage you pause the video and you plug in these values and you see if the outputs are what you would have expected. So here it says, what is the output of the following if number is 14, 15, or 30? Let's look at 14. If number is 14, let's plug it in. 14 mod 2, it'll print it's even. Number mod 5, yeah, that's false, it's not a multiple of 5. These are two independent if statements. Now, here we have an if elif, number mod 2 equals 0. It is, that's even. We won't even execute the elif because we put this together as an if and elif, which it's fine on this example. But now let's check for 15. 15 mod 2 is not even, okay, but 15 is a multiple of 5. It's an independent if statement. That works. Here, this if is false for 15, so it's not going to print it's even. And we will come to this true, to this elif, which 15 mod 5, it is divisible by 5, so it'll print it's a multiple of 5. That works. What's the problem? The problem's on 30. It's not going to give us the expected output. Because here's an example of where we maybe wanted independent if statements. 30 is in fact even, so this is going to be true. We'll print 30 is even. 30 is also a multiple of 5, so we'll print out 30 is a multiple of 5 because they're two independent if statements. But here, when we print 30 mod 2 is 0, it's even. That's true. It prints that 30 is even. It will not print that 30 is a multiple of 5 because this is an elif and we already found one true statement. It's not necessarily right or wrong. It just depends on what you're looking to achieve based off of your program, if that makes sense. So in this program, if you wanted to know every number that was even as well as a multiple of 5, option A would have been the better route for you to go. Another one, rewrite this statement using a Boolean expression. Pause the video and try to rewrite this statement using one line of code that we showed earlier. Not the 4 lines, one line. Pause the video, a nice pause for emphasis, and then here's the solution. This one, to be very honest, I feel this way when I was a new student, like, what's going on here? How is that working? It makes no sense. Well, it does. When you realize this is an assignment, we bring our eyes to the right, we realize that this is a Boolean expression, it evaluates the true or false, and we save that into the variable new line. All right, I'm looking at the time. Logical operators, this is the next major thing within this chapter. So we've seen how we can use conditions to determine whether or not we should execute a statement. We have these if-else statements. We have these nested if-else statements, multi-way statements. But what if we now have multiple conditions that we want to check? Instead of using nesting, instead we can use logical operators and, or, as well as not, that allow us to check a more comprehensive or a more meaningful Boolean expression. So here we have not. These are the actual Python operators, which is so beautiful. In other languages, you don't type the word and or not. You instead have to type certain characters. Python, a wonderful language in that regard. So not will negate. So if you type in just not true, check this out. If I just want to print over here, print, how about this? X equals 5. Print, does X equal 6? That will print, of course, false, right? What about this? If I print not of X equals 6, what's going to happen now? That will print true, because this is saying all of that's false, and not false is the negation of false. That will give you true. So what remains is when I see these logical operators, we want to look at a truth table for each one to understand how those operators work. But the good news is we already understand this, because these are things we use in our life, words that we use in our life, and I'll go through some examples. So truth tables, we use them to show the truth value of Boolean expressions. So as an example, the truth table below that we're going to see shows the truth value of not p. So given a variable, a Boolean variable, p, it can be either true or false. Not p will simply give you false or true. So it's called a truth table because you would normally depict it here in a table. You would say here's p. What can p be? P can be true or it can be false. Well, therefore, not p. Well, if p was true, what is not p? False. If p was false, what is not p? True. That's your basic truth table. And here is an example that was given in the textbook. They used age, they used gender. I make no assumption of gender being binary. I want to throw that out there here. But nevertheless, they simply had two genders, male and female. And we have here as an example, not age greater than 18, it says is false, because it says assume age is 24. 24 greater than 18? That's true. Not true, absolutely false. Or not gender equal M, they said assume that gender was F. So F does not equal M, that is going to be a F does not equal M, that is a false statement. F does not equal M, so therefore that's false. And not false will be true. Okay, so this is your truth table for not. What about and? And is funky at first, but just think about it logically. I'll give an example. If we say that, gosh, this weekend we're gonna do something cool outside, or we're gonna go tonight for pizza. If it is, we're gonna eat pizza tonight. I don't know where, of course you know where pizza came from. We're gonna eat pizza tonight if it's a weeknight and if there's a sale at the local pizza chain. Whatever, it's a weird example. But if I tell you that we're gonna eat pizza tonight if it's a weeknight and if there's a pizza on sale at the local pizza chain, when is that statement gonna be true? It's gonna be true if, in fact, we eat pizza tonight and it's gonna be true if there is a sale and if it is a weeknight. That's exactly what you would have expected. You know what? I am giving a wrong example as I think that through. That's actually implication in the laws of logic, which is super easy. I'm giving implication. Scratch the last 20 seconds. This is a live video, live stream. That's all right. Let's make this even easier. How about if I were to say this? We are on page 71 and we are talking about chapter 4. I made two claims. We're on page 71 and we're talking about chapter 4, which you can see right here. Is that a true statement? Yeah, it's a true statement because both of those things are true. Now, what if I say we are talking about selections and right now we're on page 40? You would say, no. Can you not read in the bottom corner of your screen? We're on page 71. So if I say we're on page 40 and we're reading about selection statements, you would say that's not a true statement. Meaning, if I stated something false and something true, the whole result is false. If I were to say we're on page 71, which we are, and we are reading about a thing called loops, you would say, no, that's not true. We're currently reading about selections. So the overall statement with and is only true if both of my statements are true. We're reading about chapter 4, and we are in fact on page 71. So this is for and this is the one for or. How does or work? Or simply says that a given compound Boolean expression is true as long as one of the values is true. So if I were to say, hey, we're on page 71, or we're talking about loops, you'd say, yeah, that's a true statement because we're on page 71. We're not talking about loops, but we're on page 71. That's right. I could have also said, we are talking about chapter 4, selections, and we're on page 30. But I said, and we're on page 30, so that would be a false statement. Let me use the or. We're talking about chapter 4 selections, or we're on page 20. You're like, we're not on page 20, but we are talking about selections, right? Or if you were to say, tonight I'm going to eat either a salad or I'm going to eat 2 slices of pizza. You make that claim. I'm going to either eat a salad or I'm going to eat 2 slices of pizza. Well, when were you truthful? If you ate a salad, you were truthful. If you ate 2 slices of pizza, you were truthful. Heck, if you ate both of them, you were still truthful. But if you ate neither of them, your claim or your statement of that you're going to eat one of them would have been invalid. The takeaway is the or, this should say or right here. Or is going to always be true unless both of them are false. If I say, we are reading about loops right now, chapter 5, loops, or we're on page 18, you would say, we're not talking about loops. We're also not on page 18. Neither of those statements are true. Therefore, the entire statement that I just gave you is a false statement. So you could look at the examples here. They give examples with gender and with age, and you could read over these examples. But this might be the first time for some of us that we're being exposed to these logical operators of and or. And it takes some time to get used to it. And then it really helps, of course, to begin solving some problems with them. So here, let's look at a table of such examples. Assume x is 1. Here we say true and 3 greater than 4. Well, there is no x right now. So start with the 3 greater than 4. Is 3 greater than 4? Nope, that is false. True and false, that's going to be false. Come back to this table. The only time, if we're dealing with and, the only time the result of P and P2, P1 and P2, the only time it's true is if both statements are true. So here, true and false, that's going to be false. Let's look at this one. If x is 1, 1 is greater than 0, that's true. 1 greater than 0 here, that's true, but not true is false. False and true is going to be false again. Let's check out this third one. 1 is greater than 0, that's true. Or 1 less than 0, that's false. That's really true or false, which is going to be true. And let me tell you, the way a programming language works, once it sees that we have if we're using or, and once it identifies or it sees that we have one true, it will ignore the rest of that expression. As an example, if we come here and we have this code, for example, if we have true, true, or false, or false, or false, to infinity, or false. Imagine we had that 100,000 times. The entire answer is true, because true or false is going to be true, And that thing ORed with this will be true, ORed with that will be true. True ORed with anything will always give you true. So that example is going to give you true as well. 1 greater or equal to 0, that's true. I don't even need to evaluate this. And finally, let's take a look at this one. This is nice. 1 does not equal 1. Does 1 not equal 1? That is a false statement. 1 equals 1. That would be true. But here, 1 not equal 1, that's false. Now let's come over here. 1 equal 1, that's true. But not true is false. So what do we end up with? We end up with false equal false. And guess what? That's a true statement. False does equal false. That is, in fact, a true statement. So we want to end by revisiting. Let me confirm. Yep, by revisiting this rock, paper, scissors example. And instead of using all of this nested, which wasn't too bad. It wasn't too bad using nesting. But instead of using nesting, like we showed here, let's now use these logical operators. Let's see how we can change this. And so what I'd like to do is copy, let me just file, save as, and I'll save this as rock, paper, scissors _ version 2. So now what I want to do is, instead of nesting, check this out. We're going to say if computer choice is 1 and choice user is 1, I'm going to print that. And now I'm going to take this and I'm going to merely type elif the computer choice is 1 and the user choice is 2, print that. Elif the computer choice is 1 and the user choice is 3, print that. And let me fix this alignment here, the indentation. So now notice what I did here. There's no more nesting. If the computer choice is 1 and the user choice is 1. If the computer choice is 1, user choice is 2. Computer choice is 1, user choice is 3. Well, guess what? Now we're going to do that exact same thing for if the computer chooses 2 or if the computer chooses 3. So it's probably just easiest to highlight this. I hope you can code this as well. It's absolutely one you want to code up. But I'm just going to highlight the options that I already have for me. So this is computer chooses 2, but the user chooses 2. And then we want to have computer chooses 2 and the computer and the user chooses 3. So here, computer chooses 2 and the user chooses 1, 2, or 3. And we have the final setup where the computer now needs to choose all option 3. Bear with me. So here the computer chooses 3, the user chooses 1. Here the computer will choose 3 and the user will choose 2. And then finally we have an else, but I'm going to put as a comment to show what this else really means. Else, it means that the computer chose 3 and the user chose 3. So this was nice, and that was fast. I want to go over this. But instead of, let me open this up, instead of rock, paper, scissors version 1, this wasn't bad though. So this may not be the best case where you'd feel like it's so much better this way. But nesting can get really nasty. And so here we had to nest. Why? Because we didn't know how to check the computer's choice as well as the user's choice in one go. So we had to check if the computer's choice is 1. Inside there, now let's nest these other options of the user's choice. But now that we know that we can use this Boolean, this logical operator, if the choice of the computer is 1 and the choice of the user is 1, print this. Elif the choice of the user is 1 and of the computer is 1 and the user is 2, print this one. Elif of the choice of the computer is 1 and the choice of the user is 3, print this one, and so on. So let me debug this. Let me hit stop. I want you to see that's viewed as one complete statement. I'm zoomed out just a little bit. I just want to print this at the end, just so you can see that I've made it to here at the end. And let's debug this. And of course, we need to print the menus. Let me hit step over on all of this. Get the choice from the user. Let's enter 3. Let's step over this, step over that, and here we are. So I entered 3. I did not even see what the computer entered. We're about to find out. Let me hit step into. The computer choice is 1 and the choice of user is 1. So apparently the computer chose 2. So we have 2 equal 1. That's going to be false. And check out what happens here. False ANDed with anything. I don't care if you have a million truths. False ANDed with anything is going to be false. And as a result of that, the interpreter is not even going to waste time looking at this. Check out what happens when I hit step into. It's not even going to waste time evaluating that because the whole thing's already false. So it won't do line 24 and it looks at the rest. This is going to take a while because we have my choice was 3. No, my choice was 3 and the computer's choice was 2. So that's going to be false. This is going to be false. This is going to be false. Oh, that was true. The computer's choice is 2, but my choice was 3, so that's false. The computer's choice is 2. That's true, but my choice is 3. This is still false. So now we're here. Now Python's looking at the rest of this statement. Computer choice is 2. That's true. The user's choice was 3. That's going to be true. True and true is true. And so now we're going to print this statement, the computer's paper and your scissors, you won. That gets printed. And now the rest of the block is skipped. And we come down here to the end and we print this statement at the end. I really encourage you, type this one up completely. Run it through the debugger several times to get comfortable with what's going on, to get comfortable with the and, with the or, when those evaluate to true, when those evaluate to false. Get comfortable with that, and we will then pick it up next time. It's been fun. As always, reach out, leave a comment if you need anything. Take care.